sorry about getting cut off there. Didn't realize I was at the end of my time. Alright, what we're talking about is that this is in plants, like we discussed here, in plants and some algae, there's that alternation of generations. Your fertilization of gametes results in a diploid sporophyte. Okay, the difference in plant versus animal here are your sporophytes, which we talked about here. Your diploid organism is your sporophyte. Okay, is the result of fertilization of your gametes. Big difference, plants and animals. We talked about that there are multicellular haploid individuals in the plant side of the spectrum. Okay, continuing on, looking at fungi and protists. The only diploid stage is the single-cell zygote. There is no multicellular diploid stage. Okay? No multicellular diploid stage. The zygote produces haploid cells by meiosis. Each haploid cell grows by mitosis into a haploid multicellular organism. The haploid adult produces gametes by mitosis. Okay, so this one doesn't have to have its chromosomes because most fungi and protists hang out in a haploid state, so they don't have to go through meiosis to divide their number. Just that zygote goes through and produces those haploid cells. Okay? A little different there, but good to note. Alright, continuing on. Here showing you have your haploid unicellular or multicellular organism. Alright. Remember, haploids N, diploids 2N. Okay. The only time you're 2N with protists, alright, protists and fungi, is in the zygote stage. Okay. Depending on the type of life cycle, either haploid or diploid cells can divide by mitosis. However, only diploid cells can undergo meiosis. Okay, only a diploid cell can undergo meiosis. It has to have two sets of chromosomes to be able to divide those chromosomes apart. Makes sense, right? Alright. In all three of these life cycles, the having and doubling of chromosomes contributes to the genetic variation in offspring. Without this change, without this having and doubling, moving certain genes to certain locations, moving certain genes that code for certain traits, without this variation, you wouldn't have, variations on a thing. You would end up with clones. You'd end up with identical copies. So it's very important that we have this variation in your chromosomes. Okay? Because compounding of traits, like you see when you look at examples like the British royal family or the Blue People of Troublesome Creek, Kentucky, they are a prime example of what happens when genetic abnormalities, hemophilia, or a blood disorder, compound. That becomes, instead of the recessive trait, that recessive trait becomes found in the majority of your individuals. So you need that variation so that your genetic defects do not have such a stronghold in your lineage, in your family line. The more variation you bring in, the more those genetic defects that are carried, those recessive disorders, the less likely they are to appear in individuals in your family. Okay, that wraps up 13.2. Sorry I had to go over just a little bit. We will continue on with 13.3 and 13.4 very soon. If you have any questions, please let me know. Make sure that you answer your checkpoint questions. Make a list of questions for me. Friday we will be reviewing. Thanks, guys. Bye.